if you were a computer doing the packaging type system that we've been talking about, then you don't have two hands to work with. You only have circuit boards with circuits that are open or closed. It's like an on or off switch. It's essentially like having just two fingers. Anytime you have more than one of something, you don't have enough, you run out of fingers as soon as you have two of anything. So you're going to have to do a lot more packaging. If you just have one of something, you're fine. But the moment that you have two marbles, another one and another one, you're going to have to package those two marbles together into a computer package. Now, if you just have one of these packages, these small packages, you're fine. But the minute you get another one, you've used up all your fingers if you've just got two fingers to work with. And so you're going to have to package those two guys together into a larger package. This would be a medium size, let's say. Now, if you just have one of these, you're fine. But the minute that you get another one like it, you've got two. You've used up all your fingers. You've got to package them together into a larger sized package. And we keep going. Well, if you get two of these, you've got to package them together. So when we were doing alphabet counting, because there's a lot of letters in the alphabet, we didn't have to throw our marbles together into marble bags very often because we had a large alphabet, a large counting system to work with. This is kind of the opposite extreme. With a computer, you've only got two fingers to work with, on and off. You have to do packaging a lot more often. So we're doing a lot of packaging here. The moment I get two of these, I've got to package them together into a package of this size. And the moment I get two of these, I've got to package them together into a larger package still. So if you're doing packaging with a computer brain, you get this system that, well, it kind of looks like a Empire State Building, a large building, or a multi-layered cake, or even if we take away some of these drawings, it actually looks kind of like it could be a networked computer system with a bunch of flashing lights that are flashing whenever the network is working, kind of like a computer on the internet. But that's just a coincidence that it happens to my picture happens to look like that. So that the next question that we need to consider, we can, if we realize that this is how we have to package things with the computer brain, is, well, if we're going to write things down, now computers don't necessarily write things down, but if we were going to try to communicate with each other in computer language, what kind of symbols would we use? How many numerals would we need? In the alphabet system, we had A, B, C, all the way up to Z, and then we had a space for 0. In the two-handed system, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, and we had this symbol 0 to represent none of something. Well, what if we're working with computers? Well, we need to represent none of something. We're still going to use 0. This is just what people commonly use. Of course, you could have come up with another system, but we can still use 0 to represent none of something. And then if we have 1 of something, we can still use the numeral 1. Well, what happens if we have 2? We don't write the number 2 anymore, because now if you have 2 of something, then they're packaged up into a larger sized package that you just say, instead of saying I have 2 marbles, you just say I have 1 package of this size. Instead of saying I have 2 packages of this size, you just say 2 packages of this size means 2 of these means 1 of these. So we don't need the numeral 2 anymore, because if we have 2 of something, well, we've packaged them together into a larger sized computer box, and so we have, anytime we have 2 of something, that means that we have 1 of something bigger. So it turns out that to write a number in computer language, all we really need is to know if we have 0 of something or do we have 1 of something. You can see a pattern here. When we were using the two-handed system, we needed the numbers 1 through 9. We didn't need 10. We just needed the 0 to represent none of something, and then 1 through 9. And if we got to 10, that just meant that we had one two-handed package. If we're dealing with the computer system, we don't need the number 2. It's like we don't need a symbol for the number 10 if we have 10 fingers, because 10 is just a 1 and a 0. If we're working in a computer system, we don't need a special symbol for 2. We just say that if we have 2 of something, then we just have 1 of those 2 things packaged together. Now see if you can come up with some example using just some 0s and 1s of different numbers of marbles in computer language. That's what we're going to look at next, but see if you can stop and come up with some examples on your own first.